Okay, so today we're going to work on trig identities. I'd like you to copy these equations. I'd like you to solve these equations. I'm going to pause the video, and then we're going to come back and have the solutions on the board. Once again, I know that this is going to be sine, cosine, and tangent. I just want you to imagine this is like an 8th grade, 9th grade, 10th grade math class, and you're solving these problems. Okay, so here's the solutions to the first four. Let's talk about this. So 3x equals 5, 3x equals 1, s is 1/3, 0, 9, 0, 1/2. Pause the video if you got this wrong, but the idea is we're not looking at s, c, and t, we're looking at sine, cosine, and tangent. Well, we don't have cosine. The idea is the equation is actually 3 sine theta plus 5 equals 6. Well, we solve it exactly the same way, but our solution is actually sine theta equals 1/3. Two things. We're going to be in degrees, and we're going to go from 0 to 360, just to make it easier. So how do we solve this? Well, we don't know this. This is not one of our special angles, 30, 45, 60. It's not 0, 90, 180, like 0, -1. So we have to use the GDC. Theta is equal to the sine inverse of 1/3. This is really tedious, but the good thing is you get to practice, whether it's positive or negative. The sine of an angle is positive. We know it's in the first or the second quadrant. We know that theta, the reference angle, is, it is 70.5 degrees. And to get to in the second quadrant, we take 180 minus 70.5, which is equal to, what is that? That's 109.5 degrees. Nice. Let's take a look at the second one. The second one is, it was, 2 times s minus 1, but it's actually, the equation was actually, 2 sine theta minus 1 equals -2. So we've got the solution of sine of theta equals 0. Well, that's easy. We know from 0 to 360, we remember the graph. It's 0, 180, 360. So theta is equal to 0, 180, 360. Know how to go from degrees to radians, they might ask. Good. Let's look at number 3. This is number 2. Number 3, the equation we saw for number 3 was that long thing, but it was actually 4 tangents theta plus 2 equals 2 times 3 tangent theta minus 5, and we got the solution, tangent of theta equals 9. Now, we don't have to worry about, it being over 1 or -1 or 1, because tangent, the range is infinite. It's all the real numbers. So we take the inverse tangent of 9, okay, and we get 83.6. And we're in good shape because the tangent is positive in the first and the third. Well, how do we find that third quadrant angle? We'll just add it to 180. And we get 263.6 degrees. So these are our 2 answers. The fourth equation was actually 2 sine squared theta. Remember this notation, it just means sine, the value sine squared, minus sine theta equals 0. And we got the solution that sine of theta equals 0, or sine of theta equals 1/2. Well, we did this before. We know that theta is equal to 0, 180, and 360. The question is, what is this angle? Well, we know it from practicing. We know that the sine of 30 is 1/2. So we know that theta is 30 degrees. The question is, where is sine positive? It's in the first and the second, and therefore, how do we know it's 150? Or a visual, if you need a visual. Can you see over here? Yeah, you can see over here. A visual is, here's 30, rotation. The question is, that's 150, because that has a 30-degree reference angle. Okay, I'm going to pause the video. Okay, so here's the answer. Let me just roll on my shirt. Anyway, here's the answers. This is how you so c squared minus a fourth, c squared equals a fourth. So c equals this. You undo the root, the square. You take the square root of both sides, plus or minus. Or you could look at that and say, hey, you know what, Mr. Heather, that's the difference of two perfect squares. C minus a half times c plus a half. Now we know that's not this actual original equation was cosine theta minus a fourth equals 0. So the solutions are actually the cosine of theta equals a half, or the cosine of theta equals negative a half. And so we have 4 solutions for this quadratic. It's kind of interesting. So let's take a look at this. Well, we know these. This is 60. So we know the reference angle for all of these is 60 degrees. So cosine is positive in the first and the fourth. So theta is equal to 60, and to find the angles in the fourth quadrant, just subtract it from 360, so it's 300. Now the question is, cosine of theta equals negative a half. We also know that the reference angle is 60, but we're in the second and the third quadrants. So the question is, how do we get to the second quadrant? Subtract 180, subtract 60 from 180. And to get to the angle in the third quadrant, you're at 180, go 60, 240. Nice. Let's look at number 6. Number 6 was a very basic monic quadratic, t squared plus 2. But we know that the actual equation was the tangent square theta plus 2 tangent theta equals 15. We had 2 solutions. The tangent of theta equals negative 5. And the tangent of theta equals 3. These we're going to have to use the GDC. So first of all, the inverse tangent of negative 5 and the inverse tangent of 3. Now, we're looking for a negative. This is interesting. Because I want you to, I'm not going to show you on the calculator when I get this done, but please ask me if you have any questions. When you take the inverse tangent of a negative number, it's going to bring you to the angle in the fourth quadrant, but it's going to be like negative. Instead of like doing like 290, it's going to be like negative 70. Now let's see what the answer is. The inverse tangent, the reference angle, what the answer in the GDC is going to say negative 78 degrees. That's the reference angle. The reference angle is 78, but because you want the inverse tangent of a negative number, it's going to take you to the fourth quadrant, and you can use that to find the second quadrant. Well, if the reference angle is 78, first of all, 360 minus 78 is equal to 282. And I also want the second quadrant, because once again, tangent is positive and tangent is negative in the, so hold on a second. Sorry about that. So the GDC gave us an answer of negative 78. This is the reference angle. We need the angle in the second and the fourth quadrant. 360 minus 78 is 282. And then to get the second answer, let's do 180 minus 78, which is 102. These are 2 angles. What's going on here? The tangent, the inverse tangent of 3. Well, it's positive. We know we're in the first and third quadrants, and our calculator is going to give us the reference angle, which happens to be the angle in the first quadrant, which is 71.6. And how do we get to the third quadrant? Well, you know what? We're at 180. Let's add another 71. 251.6. So what's interesting now is with these trigonometric quadratics, we're actually getting 4 answers. Let's move on to the last one, number 8. I skipped number 7. I kind of need to go back. Number 8, same idea. It's 3 sine squared plus 2 sine squared minus 1 equals 0. Sine of theta equals a third. Sine of theta equals negative 1. It's an or. Theta equals the inverse sine of 1/3. Use your GDC. Sine is positive in the first and the second. The reference angle, let's see what I have here. The reference angle is 19.5 degrees. And we need to get the second quadrant. Let's do 180 minus 19.5, which is 160.5. What's going on here? The sine of theta is -1. We like that. That's 270. We're done. Sometimes quadratic have one solution. They can have no solutions. They can have two solutions. Maybe they have three solutions. Maybe they have four solutions. You don't know. But that's the great thing about quadratics. I'm gonna come back in a second. Okay, I'm back. So there's a couple of little interesting trick things. Well, the first one I wrote up here was well, let's look at another equation. Here's number 9, I guess. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Here's number 9. Let's take a look at this one. 5 sine x equals 3 cosine x. And it looks kind of weird, and it might show up, but the question is, can we use an identity? And the answer is, yeah. What you're going to do is you're going to divide both sides by cosine, and you're going to divide both sides by 5, and you're going to end up with sine over cosine equals 3 over 5. And you're like, what do we do this? Well, you might recognize that sine over cosine is an actual identity. It's actually tangent of x equals 3/5. And you can inverse tangent of 3/5. It's the first and third quadrant. But recognize this. It shows up here and there. The next thing we have to talk about is this equation here. Well, okay, and let's use that to solve this equation here. So what was it? Sorry. Let's see. This was number 7. And number 7, let me rewrite this. It was 2 sine theta cosine theta minus sine squared theta equals 0. So what do you do with this? Well, you say, okay, you know what? It's a quadratic, but regardless, whenever I have any type of equation, I want to try to factor. If I can factor, I'm in good shape. So you know what? Let's plot a sine theta. And what we're left with is 2 cosine theta minus sine theta equals 0. Okay, well, sine of theta equals 0. That's one thing. The next thing we have 2 cosine theta minus sine theta equals 0. And we have 2 cosine theta equals sine theta. And kind of, you say, you know what? It's that tangent thing. So we have tangent of theta equals 1/2 ... That's the idea. What other things do I want to talk about with this unit? I want to talk about the double angle substitutions. So I want to talk about how trig quadratic equations arise from double angle. Because, there's no point I taught it to you. Now, if you think about this for a second, if you look at this equation, this actually, the original equation was sine of 2 theta minus sine squared theta equals 0. Or, I could have written it like this. This is the equation you could have seen. So let's deal with this first. The second you see sine of theta, sine of 2 theta, turn it back into immediately rewrite as 2 sine theta cosine theta. Because once you have all the cosine signs in the original, like the reduced form, not reduced form, I can't think of the word right now. It's just much easier to manipulate and solve like an algebra equation. You can't do this with, actually I'm not going to show you, but you can't do these quadratics when, you need sine of x and sine squared of x. You need cosine and cosine squared. You can't deal with the 2x. So we turn it into this, and then we create it like this, and we can easily solve. Next. Sorry, I'm a little skittish. Let's look at. Okay, let's pick this up. Sorry about that. So now let's look at the other double angles. Let's look at the cosine of 2x. Two examples. The first example is cosine of 2x plus 3 sine of x equals 1. You have the cosine of 2x. The second you see cosine of 2x, you're interested, you know it's a quadratic equation. I mean, you could put this in your graphing calculator, and set it as, put this curve in, also put the curve y equals 1, but we can solve this algebraically. Because there's sine here, we need every term to be a power of sine, and so we're going to use our Pythagorean identities. So recall from yesterday, this is 1 minus 2 sine squared of x plus 3 sine of x equals 1. Now we have just a basic quadratic equation. You can write, using s's and solving quadratics. For SL, it's probably going to be easy to factor. This is a little advanced. We have negative 2 sine squared x plus 3 sine of x. Sorry, change this to 2. So we have minus 1 equals 0. And then we have, I'm going to put the negative through. So we have 2. I'm going to change this to s squared. Minus 3s plus 1 equals 0. And this factors into 2s minus 1. S minus 1 equals 0. So we have s is equal to the sine. The sine of theta equals 1/2. And the sine of theta equals positive 1. This is easy. Theta equals 30 and 150. And the sine of 1 is 90 degrees. Let's look at another example when we see cosine of 2s to an equation. It's probably not going to show up. It might show up, and you can always solve this in the calculator. Let's do the last example, and then we're done with the video. Let's see. We have 3 cosine 2x minus 5 cosine of x plus 2 equals 0. The second you see cosine 2x, you probably know you're going to be needing to use one of the Pythagorean identities, and it's going to be quadratic. Let's change this. 2 cosine squared minus 1 minus 5c plus 2 equals 0. Let's see, 6c squared minus 3 minus 5c plus 2 equals 0. 5c squared minus 5c minus 1 equals 0. Factor. It's probably not going to show up, but if it does, then use your calculator, or this will see if you're a 6-7 student. What do we have here? We have 6c negative 1 positive 1, and then so cosine of theta is equal to negative 1/6, and the cosine of theta is equal to 1. This I can do on my own. What is this? It's 0 and 360. This one you need the calculator. It's negative. It's in the first, and let's see, I can do this right now. Let's see, so we turn our calculators on, and we do trig inverse cosine negative 1 divided by 6, enter. It gives us 99 degrees. It gives us the angle in the second quadrant. And then we need to figure out, let's see, we can figure out, let's see, in the third quadrant, we have 180 plus 99.6, which is 279.6. And these are the solutions. So I'll give you some problems and you'll work on them. Thank you.